Welcome to everybody. Yes, today let us take the last part of conic session. Okay, that is the parabola. Yeah. So the parabola is a very interesting shape. That is very interesting, as I said. Okay. So let's have a bit of explanation about this. Okay. So the parabola, this is a locus of a point which moves so that the distance from the focus is equal to the distance from the directrix. Okay. So for a parabola, the distance is equal. The distances, they are all equal. But in the case of the hyperbola, as I said in a previous video, the distance will be greater than the distance from the directrix. Okay. So this is a general view or a general diagram of a parabola. Yes, we have this. Now let us have the standard equation of a parabola. Okay. So the standard equation of a parabola will be given by y squared equals to 4ax or x squared equals to 4ay. So these are the two standard equation of a parabola. Okay. Very simplified. Okay. So now in the equation of the parabola, now we center m and m. We have that y minus m all that squared equals to 4a into x minus n, or we have the other part, that is x minus n all that squared equals to 4a into y minus m. Voila. Now take note, for the hyperbola we have so many things to take in considerations. You've by having the equation. Okay, by the end of the video we are going to solve an example and we are going to understand all these different terms that we are working with. Okay, so now let us have the steps to follow in sketching a parabola. So a parabola y minus m all that squared equals to 4ax minus n lies on the x-axis. Straightforward and direct. Okay, there's no particular condition. It's only if the equation is in this form, then it lies on the x-axis. Okay, and for the second form, it will lie on the y-axis. Okay, yes. So let us now study our different cases to get some derivations. So for the first case, that is the case A, the eccentricity E is equal to 1, as we all know. Yes, for a parabola, the eccentricity equals to 1. Now the focus F and its the focus F is gotten from the equation F equals to x minus n equals to a and y minus m equals to 0. So for this case, the parabola is completely different from the other forms. The derivations in the different cases do not resemble. Okay, so here for the focus, we have x minus n equals to a and y minus m equals to 0. So here we only have one point, f1, that is n plus a and m. For the directrix, is gotten from the equation d equals to x minus n equals to negative a for this case, and y minus m equals to 0. So in the case where you have an equation and they ask you to verify, if you have a parabola that they tell you the eccentricity equals to 1, just note that for the focus and the directrix, it will be direct to have their equations. Okay, one is x minus n equals to a, and the directrix is x minus n equals to negative a. Okay, for the case where it lies on the x-axis. Now our vertex, thing to note, the vertex equals now to the center. Okay, the vector equals to the center, that is m. Now the lactus rectum, one of the terms I was saying we are going to discover, the lactus rectum here equals to 4a. Okay, because from our equation we have something like x minus m all that squared into equals to 4a. Yes, equals to 4a into x minus n all that squared. So what you need to know is that therefore a there is the lactus rectum and the focal length is a. Yeah, focal length, we already see something talking about optics, but yes, it is going to help us very well in our plotting. Okay, now for the case B, the eccentricity is still equals to 1. So the focus will be gotten from this equation. Now is x minus n equals to 0 and y minus m equals to a, and it's f1 for the first line. We have n and m plus 1 plus a. For the second thing, for the directrix is still the same. You have a negative a here. So for the case A and the case B is just the same. It's just that for this case is now y minus m equals to negative a. We take but now the other side. Okay, it was normal x, now it's now y. So the vector still equals to the center, the lactus rectum is the same, and that's all. Okay, so for example, find the vertex, center, focus, and the directrix of the parabola y minus 1 order square equals to 4x minus 8. Very simple, right? It's just a small illustration. We are going to solve it, and you see there's so many terms I will explain in. Okay, so first of all, we rearrange this equation. Let it look the general form that we know. Okay, so the general form that we know is in this form. So we factor out 4, you're going to get x minus 2 in the bracket. So this one is an equation of a parabola with center 2 and 1. Center or vertex, they are the same. Okay, for a parabola, the center and the vertex are the same. So let us now have our focus. The focus is given by, because we discovered that this one is lying on the x-axis. Okay, take note, it's lying on the x-axis. So our focus is given by n plus a and m. M is 1, n is 2. We just take a. What is a now? 1. From the general form, we have what? Y minus n order squared equals to 4a into x minus n. Okay, so with that now, our a in this case is 1. So you just have to say what? N plus a is 1, m is 2, n is 2, so you get 3, 1. That's our focus. For the directrix is negative a, so you're going to have what? 2 minus 1. You have 1 and 1 for the point. Now the lactus rectum equals to 4. The focal length equals to 1. Okay, 4 times 1, that is 4 times a, we have 4, and the focal length is 1. So you can see it's very, very, very interesting. So now let us have the plot. Now let us explain the diagram. Because in some cases you can have all your points, but you're unable to plot because you don't know how to really understand your diagram. Okay, so for this particular case, for the parabola, we first of all have to start by drawing the directrix. Okay, this is the easiest point to plot. Okay, so one thing, you can start by plotting your directrix. You localize the point and you draw a vertical line that will pass through. Okay, after that, now you locate your center. Okay, once you have your center, the center equals to the vertex for the parabola, so you have this. Now the next is to have your focus. Okay, you pull your focal point. Now one thing you need also to note, that when you talk about focal length, now the focal length is the distance between the center and the focus. Okay, because you discover, after you have plotted the point, you will discover that the distance separating the center and the focal length is 1. Okay, so for my scale is exactly 1. That is it. Now the lactus rectum comes about to discover the length of opening, something like this. So this distance from this end here to this other end here is our lactus rectum. Okay, and we get that distance will be equal to 4, as we know. So we just have to open from the focus 2 units upward, 2 units downward. Okay, from the focus, you understand. So that's how we come about to plot. You don't have to go following your points and all the rest, and you have a correct diagram. So these parabolas are very, very good, because many of us don't know its main application. For these particular things, their main applications is just like is in having our normal parabolas. Yes, where the one we used to have cable signals in the house, or for transmission of channels and all the like. So that is one of the main or the biggest application of this topic. That is a hyperbola, parabola, all the rest, even ellipse. Okay, so they are used in different fields. So you really need to take this topic very serious, because it's going to, if you really master it, you're going to be in good position. It's going to help you very well. Okay, so that is all for the video. Thank you all for watching. Like, comment and share. Okay, please, even comments are really important. So if something is have been clear for you, so just notify and say yes, it's clear now, and all the rest, you'll be good. Okay, so thank you. Don't forget to share to your friends. Okay, if you discover something, don't have it for you alone. Okay, it's always good to share. Okay, so thank you, and welcome to MadLab.